Citi Bike Trip History Interactive Map. Inspired by Citi Bike's Find a Bike interactive map, I wanted to create an interactive mapping tool that visualises Citi Bike use in the last 30 days. The main aims were to take open source trip history CSV data and map this over time as an animated interactive tool. This could be used to design and plan urban transport links. I wanted to visualise which stations are popular and where additional capacity is needed. This could inform future expansion of stations. I then wanted to create a map that the user can interact with through mouse controls and show responsive hover effects. The map should be easy to use so that anyone from a transport engineer to a local authority board member could infer information from it. A Mapbox API static map centered to New York was loaded as the base of the interactive tool. The circle diameters represent the number of bikes at the station by cross-referencing the unique station object array with the trip data object array every time draw is called. This means the stations change size when the bike leaves or arrives at the station. To improve the responsiveness of the program to user interaction, the cursor changes from an arrow to a hand when it's hovering over objects that can be clicked. Callout tags are also displayed next to a station, and the diameter decreases slightly when the mouse hovers over. The buttons animate by changing colour depending on if they are active and selected or if the mouse is just hovering over them. Finally, the user is able to pin a station to track it by clicking on it. This makes a new window appear under the animation control box. I created a new HTML template file with new CSS classes to output my program in a user-friendly way, matching the style of the official Citi Bike website. Text explains what the tool is used for, and a link is provided to the source of the CSV data, which opens in a new tab. A list element explains how to use the animation controls, and lastly, the Open Sans font used is loaded through a Google Font API. All necessary global functions are defined at the start of the program, and some helper functions are also in the main program. However, use of classes was maximised wherever possible. By calling operations and functions from classes, the main program is easy to read, debug, and allows for less errors and better overall structure. This is helpful if the code is passed on to someone else to update in the future. By using classes, it's easier to keep track and update of variables such as images, padding widths, UI element dimensions. This makes parameterization easier as classes can call each other and it's clear which variables are being called. The initial station and trip data from the CSV files are passed into class object arrays when the functions are called in the setup function. This extracts the latitude and longitude of the stations, their ID number, the initial number of bikes at the station, and the station name. Here you can see the console log output of the stations array, which shows that the data is now stored and managed in this class object array, which can be called and updated continuously in the draw function, rather than reading the CSV file. Each of the 1,320 individual stations is its own object. This allows for object-oriented programming, as each station has its own properties. For example, the number of bikes at the station at any given time and its radius, a Boolean value if the mouse is hovering over it, or a Boolean value if it's selected or pinned.